Hello students, let us start a new topic, that is alkenes. So in the previous class we have seen the alkenes. Generally what is alkenes? Alkenes contains a sigma bonds which is known as saturated compounds, and also it contains a paraffins. Okay, the general formula of alkenes is here. What we can say here, the general formula of alkenes is generally CnH2n plus 2. So today we are going to discuss here is alkenes. So alkenes means here alkenes or alkynes, which is also known as multiple bonds. Okay. So this one, the hydrocarbons containing double bonds, that one we call it as what here? Alkenes. Hydrocarbon means the carbon and hydrogen which contains double bonds, we call it as what here? Alkenes. So here this is a double bond, and this one we call it as, this alkenes or alkynes we call it as in a Greek words olefins. Okay, so what we can say? Olefins. Okay, so means what we can say here? Olefins means what in a Greek word? Alkenes. So the general formula of this one we call it as here CnH2n. Okay, for alkenes we are having the general formula CnH2n. In organic compounds, the hybridization it contains sp2 hybridization, and it is a trigonal planar shape. So this is our general introduction of alkenes. Let us see nomenclature. So we have discussed already what is the molecular formula of alkene. Generally what is the molecular formula of alkene? CnH2n. If you take cyclic alkene means CnH2n minus 2, means the formula is same for everything, for alkene and for cyclic alkene. So this is consists of cycloalkene ring. Okay, one double bond is present now, because of that we are saying it is an alkene. So now see here, generally here we are having an alkane, right? So this is an alkane. So what is the formula here? CnH2n plus 2 is the formula. Okay, so by this what we can say here? It is an alkane which is known as C5H12 pentane. And if you take alkene, the formula is different. Okay, so for alkene what is the formula we are taking? CnH2n. Means what? If you substitute C5, then you are going to get only 10 carbons. So by this, at any position you can keep here. Means what we can say, if you are substituting here, then the number will change of the double bond. Means if you substitute in one carbon, the position is going to change. We have to give first priority where the double bond is present. So this is nothing but alkene. So cycloalkane is different, cyclic alkene is different. Okay, so here for cycloalkane also the formula is CnH2n. For cyclic alkane also the formula is CnH2n. So see the difference. Here for alkane you are having CnH2n plus 2. For cycloalkane you are having CnH2n. For here's alkene CnH2n. For cyclic alkene you are having CnH2n minus 2. So means what we can say, if you substitute any number here, for example C5, 10, H10, 2 5 is 10, 10 minus 2, 8. Okay, so this is the reason. Next, so let us see the nomenclature here. Generally if it contains long chain functional group. Okay, functional group is nothing but OH, COOH, and also methyl group also we can take. So here we are taking the functional group as double bond CH2. Where the double bond CH2 is present, at that we have to give the numbering. So here the double bond is present at suffix, means at last position. So there you should have to give the first priority. So means what? How the numbering will come? 1, 2, 3, 4. So by this what we can say, 4 carbons is there. 1 double bond is present. By this what we can say here? By this we can say it is a 1 butane, or we can say it as but-1ene. And now here the double bond is present in between the CH and CH. So if you can give 1, 2, 3, 4, and here also you can give 1, 2, 3, 4. Which side you give also? The double bond is present in its second position only. So by this what we can say here? It is a 2 butane. Okay. And next one, hexene. So hexene is there, no? See here the double bond is present at starting position, not at the ending position. So then where the double bond is nearer, there only we have to give the number. Okay. So by this what we are giving here, the first priority is giving this side, not this side. Why? Because the chain became very long here, very longest chain here. Because of that reason we are not giving here first priority. Okay. So in alkenes not like that. Where the chain is long, from back side we use it to count. Okay. Now here we have to give the double bond as 1, 2, 3, 4, 5, 6. Okay. So here it is presenting as 2 hexene. 1 double bond is present. That's why it is a hexene. And if you take next one, see here the chain is long. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 9. Total 9 carbons we are having. And here double bond CH2 is present. Okay. So generally see here 1, 2, 3, 4, 5, 6, 7, 8. So this chain contains of total 8 carbons and 1 double bond CH2. So what I have told you, where the double bond is present, there we have to give the first priority. So in this no double bond is present. Here the double bond is present. So what you will do here, the double bond where you are having, that one you are going to give the first number. So that's why we have given first 1, 2, 3, 4, 5, 6. Okay. So here this is a 1 hexene. Then what about this one? This is also a functional group. And for this the functional group, see here, propane. Okay. What is the propane structure? Propane consists of C3. What is the propane we are having? C3H8. This is the formula for propane. So here in place of 8, what we are having? In the place of 8 we are having 7 molecule. That one we call it as what? Alkyl. So then by this what we can say, for this also we have to give the, by numbering we have to give first priority to alkene, but by mentioning the name you have to write here at second position the methyl group is present. No. So by this what we can say, 2 propyl 1 hexene. So this is about nomenclature of longest continuous groups. Next one, let us see if the substituents are present. Substituent means any group or atom is present on the compounds. Then here see double bond is nearer to this one. Okay, not for this one. That's why we have given, see this structure here. The double bond here is given here very near. So that's why what we are doing here, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then the substituent is present at where? Third position and also sixth position. So wherever the bond is presenting like this, we have to mention it, there will be a CH3 compulsory. Okay. So then by this what we can say here, here at third position methyl group is there, sixth position methyl group is there. Then at third position again double bond. How many carbons we are having? 8 carbons. Okay. Here also 1 carbon. Here total 8 carbons we are having. So to this carbons 2 substituents are present and 1 double bond is present over here. So by this what we can say, third position, sixth position. So numbering will be where the alkane we are having, that side we are getting the first priority. Then coming to naming. When you name the compound where the substituents are present, that one you are going to get the first priority. So means what here, third position, sixth position, 2 methyl groups are present. By this what we can say, 3, 6 dimethyl 3 octane. Why? Because here one double bond is present, no? That's why it is a octane. This is the name. So next one, if you have been seen, CH3, CH2, CH, CH, CH2, CH, CH2. So here the double bond is present at last position. That's why we have given the naming from back side. Now coming to here, for this, the substituents are present at 4th position, 5th position. We have to name them first. So means what? 5 bromo, 4 chloro, 1 heptene. Why? Because 6, 7 carbons is there. That's why we say that it is a 7 heptene. Okay. So this is nothing but naming of substituent in alpha carbons. So next one, lowest functional group. Next, what is the next rule? Which is having the lowest functional group number, then the lowest substituent numbers we have to see. So here, generally what I have told you here, 1, 2, 3, 4, 5, 6, 7, 8. Total 8 carbons is there. So here at 4th position, the octane is present. And coming to here, at which position? The carbon at 4th position, and also at 7th position the methyl group is present. So generally what we think here, 4, 7 dimethyl 4 octane we are saying. So but here what happens here, whenever you are naming like this, it is the wrong. Why it is wrong? Then what is the naming of this? So let us see here, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Here what we are doing means, which is having lowest functional group. See here, name with the lowest functional group number and lowest substituent number. So first we have to give the priority for lowest functional group numbers. That is 2, 5. Okay. Dimethyl 4 octane. This is nothing but naming of the compound. And coming to here also. Here 1, 2, 3, 4, 5, 6. At 2nd position bromine is there, 4th position methyl group is there. And coming to here, the double bond is present at 3rd position. So means what? Whenever the carbons are sharing equally, at that time the numbering is going to change here. Okay. So see here, this side 4 carbons, this side 4 carbons. The numbering is changing. And coming to here, this side, see, here also the numbering is changing. Okay. Means where the carbons are distributing the double bonds equally, at that position the naming of the compound is changing. Okay. Means the lowest number we have to give the first priority. Next one. For this, no numbering of the functional group is needed in a cyclic alkane. So here for alkenes we need not to give any first priority. Okay. For we cannot give any functional group numbering. Directly where the double bond is present, at that side we can give the numbering. So by this what we can say here, the double bond is presented here. So by this what we can say, 1, 2, 3, 4, 5. At 3rd position substituent is present. So we can say 3-ethyl cyclopentene. Why? Because there is a 5 carbons over here. If you have been observed here 1, 2, 3, 4, 5. So at 4th position, 5th position dimethyl group is there, and here we can say directly cyclohexane. No need to say numbering here to this double bond. We can directly say it is. Why? Because these are cyclic compounds. We can directly say this is cyclic hexane, cyclopentane, like this. And coming to here, 1, 2, 3, 4, 5, 6. Okay. So coming to here, we at 4th position ethyl group is there, and at 3rd position methyl group is there. So it is a 6 carbons and 1 double bond is present. By this what we can say, 4 ethyl, which is having more number of carbons. That one you have to write it first. So by this 4 ethyl, 3 methyl cyclohexane. And here also you can see 1, 2, 3, 4, 5, 6. Okay, double bond is also present over here. 1, 6th position it is there. Dichlorocyclohexane, not 2, 3 dichlorocyclohexane. Okay, like this you have to give the numbering first. Why? Because 1 is having very less number compared to 2. and here 5 ethyl 1 methyl means 1 2 3 4 5 6 means 5 ethyl 4 1 methyl cyclohexane is present, not 4 ethyl or 2 methyl cyclohexane. Okay, so this is nothing but numbering of the functional groups. Now special nomenclature we are going to have, that is vinylic carbons and allylic carbons. So vinylic is nothing but what means, so this is the group present over to the vinylic. Vinyl means CH2 double bond, CH1 bond is present. So this one we generally say that chloroethene, or we can say it is a vinyl chloride. Okay, so coming to here next one, allylic group. Allylic group means CH2 double bond, CH, CH2. So this is the allylic, or we can say 3-bromopropene, general name, but it is a allyl bromide or allylic. Allylic is different, vinylic is different. Vinylic means CH2 double bond CH. Allylic means CH2 double bond CH CH2. One carbon is coming extra. So this is nothing. And next one we are going to speak about structure of alkenes. Okay, in structure of alkenes generally one pi bond we are having, one sigma bond, which is going to give a sp2 hybridization. See this structure over here, the carbon. So it consists of, the carbon molecule consists of pi bond. Now here hydrogen will not contain pi bond. Why? Because hydrogen is having only one orbit which contains of sigma electrons, and coming to carbon is having pi bonds also. Okay, carbon is having pi bonds also. So because of that, what we can say, because of pi bonds, the carbon, so it is going to overlap with hydrogen molecule, and there will be a overlapping between the pi orbital of CC. It also contains pi orbital, it also contains pi orbitals. So that's why it is forming as a pi bond 1 sigma bond. So which will give sp2 hybridization having the angle of 120 degrees. Okay, so this is about structure of alkene. So that's all. In the next class we can see the preparations of alkenes. Thank you.